Well, one more item is important for us, and that is we should actually verify at least our half-angle formulas for sine and cosine. And so that's what I'm going to do by using my double angle formulas for cosine. And there were two of them that are really, really useful for us. The first one, cosine of 2 alpha is equal to 2 cosine squared alpha minus 1, or the second one, 1 minus 2 sine squared alpha, are both going to give us these formulas. And here's how. Let's take this first formula, where the cosine of 2 alpha is equal to 2 times the square of the cosine of alpha minus 1. What can we say about it? Well, in this case, if I have cosine of 2 alpha, let me put this in a color right here, cosine of 2 alpha is equal to 2 cosine squared alpha minus 1. Let's isolate cosine squared alpha. So what does that mean we should do? Well, the first thing would be to add 1 to both sides, so that we could say that 1 plus the cosine of 2 alpha is equal to 2 times the square of the cosine of alpha. But to isolate cosine squared alpha altogether, we'd have to divide everything by 2. So let's do that next. And we end up with this formula. The square of the cosine of alpha is equal to 1 plus the cosine. 1 plus the cosine. Let's see if my pen will actually cooperate with me here. 1 plus the cosine of 2 alpha divided by 2. Well, how are we getting from there to here? Well, first of all, this is what we sometimes call this a power reduction formula. If you end up with a square of cosine, you can reduce it by doubling the angle, as long as we add 1 and divide everything by 2. So that's called a power reduction formula. Now, we're not really going to dwell on that for right now. There are some assigned problems, I think, that might mention it, but for our purposes, for the half-angle formula, what we're really saying right here is we notice that, look at this angle. This angle right here, alpha, and this angle right over here at the end is 2 alpha. So whatever angle we have over here is doubled when we put it in this formula. So let's change it around a little bit, and let's say that, all right, instead of alpha, let's make alpha equal to theta over 2. What's 2 times alpha? Well, that's right, it's just theta. So we're saying here that the square of the cosine of some angle, theta over 2, would be the same as 1 plus the cosine of the full angle divided by 2. So now you can see, well, this is sort of an easy jump. Take the square root of both sides, and we'll find that the cosine of theta over 2 is indeed equal to, positive or negative, the square root of this quantity, 1 plus cosine of theta divided by 2. Again, we can say a lot of the same things here about this other identity. That is, we know that since the cosine of 2 alpha is also equal to 1 minus 2 times the square of the sine of alpha, a little bit of algebraic manipulation is going to allow us to isolate the square of the sine of alpha, so that we can then build this formula, sort of like what we just did. And so I'm going to do that. I would find that 2 times the square of the sine of alpha, by adding that to both sides, and then subtracting cosine of alpha from both sides, would give me 1 minus cosine of 2 alpha in place of 2 sine squared alpha. So if I divided everything by 2, as I did before, I would end up with the square of the sine of alpha being equal to 1 minus the cosine of 2 times alpha, all divided by 2. Once again, let's just do this trick right here. Let's replace the angle alpha with the angle theta over 2. That means that our angle 2 alpha is going to be the same thing as just plain old theta. So if we make those replacements and we have the square of the sine of theta over 2, we find that that is exactly the same as 1 minus the cosine of the full angle theta, all divided by 2. Since the quantity is squared, we take the square root on both sides and find that the sine of theta over 2 is equal to positive or negative root of the quantity 1 minus cosine of the angle theta, all divided by 2. And so that's what we're looking for right here. This verifies our two identities that we were looking for, and so we're done. More to look forward to in the homework. I'll see you in class.